Hello and welcome to the primaryodors.org YouTube channel. Humans have about 1,000 genes in the family of genes that codes for the proteins in the nose that detect smell. Of these 1,000, there's only about 400 that actually code for a complete functioning protein. The other 600 are called pseudogenes because they're not really genes. They're just stretches of DNA that used to be a gene, and over time they've accumulated some kind of change that broke them. One of these is called OR1E3. Now, OR1E3, according to all of the sources, is a pseudogene. It doesn't code for a complete protein because the DNA sequence has a missing letter. And that tells the cell's internal machinery that when it's making this protein, just after only about 17 letters of protein sequence, to just stop. And that's not going to work. That's not going to detect anything. It's not going to interface with the parts of the cell where the signal is carried in and where it leads to the neuron changing what it's doing. But according to one paper, OR1E3 does detect certain aromas, including acetophenol, which is one ingredient used in artificial fruit flavorings. And the smells that OR1E3 is sensitive to are associated with words like phenolic, harsh, medicinal. And that's how acetophenol smells, at least to me. Every source they've found said it's supposed to smell like fruity, floral, hawthorn, mimosa. It smells chemical and artificial. So what's going on here? Well, as it turns out, like all of the other proteins in this family, OR1E3 has different variants. And some of these variants actually do code for a complete functioning protein. So that means some individuals have a functioning 1E3, even if most individuals don't. I guess I must have a functioning 1E3. How's about that? Here are some other aroma compounds that I think smell harsh and phenolic, but they're supposed to smell pleasant. Anisole, supposed to smell like anise. It's more like benzene. Very phenolic and chemical and artificial and harsh. Anisaldehyde, supposed to be a floral, fruity anisic. It's pretty medicinal and chemical. It's not very pleasant. Estragol, supposed to smell like basil, tarragon. When it's dilute, it does, but at full strength, it's unpleasant. Cresomethyl ether, supposed to smell like ylang-ylang, anisic. When it's dilute, it does, but it's still got that phenolic chemical note. At full strength, it's very unpleasant. Although I don't know for sure that OR1E3 would respond to these other compounds, their molecular structures are not very different from that of acetophenol. So then that leads to the next question. Of these 600 supposed pseudogenes, how many of them actually have variants that work? So how many of these stretches of DNA that are supposed to be, we can just ignore them because they don't code for a real protein? Are some of us walking around with perfectly good copies of that the protein is detecting smells, contributing perceptual qualities to the experience of aroma? And so how many of these are there? We should know about all of them in order to fully understand and decode olfaction. So I thought that was interesting. I wanted to share. It looks like there's still plenty of work left to do in finding these proteins, these receptors as they're called, let alone what they're sensitive to. And I've got more of these mixtures designed to target specific proteins that I can do videos on, and I will get to in the near future. I've got analyses of what proteins they're actually going and pinging. Thank you for watching.